Welcome to Appleby Academy classes. Today we will be dealing with a relatively new topic known as sets. So if you can look at the previous year questions, questions has been consistently been asked in the previous NTA UGC net economics from this portion. So today we will deal with a previous year questions related to the portion sets as well as some other examples. So now let's begin the class. So we will look in detail some of the questions from this area. Now let's begin the section. So the first question is, if set A contains 13 elements, set B contains 8 elements and the intersection of these two sets contains 5 elements, then find the number of elements in A union B. Okay. So first we will write the information or the data that is already given in the question. First one, set A contains 13 elements, then set B contains 8 elements and the intersection of set A and B contains 5 elements. Okay. N of A means the number of elements in set A, N of B means the number of elements in set B, and N of A intersection B means the number of elements which are common in both set A and B. Okay. So now we need to find the number of elements in the union of number of elements in A union B. Okay. So when we draw the Venn diagram, the middle portion is the intersection of A and B, this one. This is A intersection B, and this entire shaded portion is A union B. Okay, the entire shaded portion is A union B. So in this question we need to find the number of elements in A union B. Okay, so there is an equation for finding the number of elements in A union B. I will just write the equation. So the equation is N of A union B is equal to N of A plus N of B minus N of A intersection B. Okay. So N of A union B is N of A, number of elements in A plus number of elements in B minus the common elements, because this is repeated twice when you take A union B. So minus the common elements in N of A intersection B. Okay. Because when you say A union B, this middle portion is counted twice. Okay. So you need to subtract that portion once from this, from N of A and N of B. So now you have 13 plus 8 minus 5, which is equal to 16. So the number of elements in N of A union B is equal to 16. Clear? I'll just explain it once more. We need to find the number of elements in A union B. So the equation for finding the elements in N of A union B is N of A plus N of B minus N of A intersection B. A intersection B means this area, this middle portion, this area which is common to A and B. A union B means this entire area, entire shaded portion of A and B. Clear? So N of A union B is equal to N of A is equal to 13, N of B is equal to 8 minus N of A intersection B, because when you take A union B, this area is counted twice. So we need to subtract this n of A intersection B once from n of A and n of B. So 13 plus 8 minus 5 equal to 16. So n of A union B is equal to 16. Okay. So that's it. Now the second question. So the second question is, write the subset of set 1, 2 and 3. Okay, we have a set. Let's name it as A. So 1, 2 and 3. We need to find the subsets, all subsets of 1, 2 and 3. Okay. So which means that we need to find the power set of A. Power set is a collection of all subsets of a particular set. Okay. So it is represented by P of A. Okay. So again there is a formula to find the number of subsets of a particular set. So the formula is 2 raised to n, where n denotes the number of elements in that set. So here we have 3 elements. Okay. So n denotes the number of elements in that particular set. So here n equal to 3. So 2 raised to 3. Okay. So in total we have 8 subsets for this particular set. The formula is 2 raised to n. N is a number of elements. So we have 3 elements here. So 2 raised to 3. 2 into 2 into 2 is equal to 8. So the total number of subsets is 8 here. Okay. So now we need to write the subsets. So, there is a rule that null set or empty set is a subset of every set. Okay. Null set or empty set. Empty set is a set which contains no element. So null set is a subset of every set, and the second one is every set is a subset of itself. Okay. Every set is a subset of itself. That means A is a subset of itself. Okay. So this is how we write it. A is a subset of A. This is a symbol that we denote for subset. Okay. So we will write the first set, which is 5. 5 is a null set or empty set. It is denoted by this symbol. Okay. So the next one is every set is a subset of itself. So 1, 2, 3 is a subset of itself. 1, 2, 3. So we got 2 sets, 2 subsets. Now we have each elements. We need to take each elements and create a subset. So first set contains the element 1, second set contains element 2, third set contains element 3. Then we need to write the combinations between these 3. That is 1, 2, 2, 3 and 1, 3. Okay, I will write it. 1, 2, 3, 1, 2, 2, 3 and 1, 3. Okay. See, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, we have got 8 subsets. See, using this formula, we know that there are 8 subsets for this particular set, and we have written down the entire subsets for this particular set. Okay. So I will just explain it once more. We need to find the subset of this set 1, 2 and 3. Okay. We have 3 elements in the set A, that is 1, 2, 3. So the formula for finding out the number of subsets is 2 raised to n, where n represents, or n is the number of elements. Okay. So 2 raised to 3. So 2 into 2 into 2 is equal to 8. This is a symbol for representing a subset. And two things that are to be remembered is, first thing, null set is a subset of every set. Second thing, every set is a subset of itself. So first we write the null set, then second we write that set itself, then each element of that set. Okay, each element of that set we are writing it as a separate subset. So 1, 2, 3 set which contains just one element, then the combination of these elements 1, 2, 2, 3 and 1, 3. Okay, hope that is clear to you. So the next question is, if A is equal to 1, 3, 4 and B is equal to x, where x belongs to R and x square minus 7x plus 12 equal to 0, then which of the following is true? Okay, so we have a set A which contains 1, 3, 4 and B where x belongs to R is real numbers and x square minus 7x plus 12 equal to 0. A condition is given. Okay, so we need to see whether A is equal to B. A is equal to B means the elements in A and elements in B are exactly the same. That means the elements in B also should be 1, 3 and 4. Okay, so that is A equal to B. Next one, A subset of B. So whether A is a subset of B. That means B is a superset. B contains all the elements of A plus some other elements. That is, A is a subset of B. Then third one, B is a subset of A. Okay, which means that A contains all the elements that are present in B plus some other elements. So that is, B is a subset of A. And the last one is, A is equivalent to B. A is equivalent to B means the number of elements in A and the number of elements in B is same. That means here you have 3 elements, so B will also have 3 elements. Okay. So in order to check this, first we need to find the elements in B. Here a condition is given, but we need to find what are the elements in B. For that, we need to find the roots of this equation. Okay, so we have x square minus 7x plus 12 is equal to 0. Okay, this is the equation. Now we need to factorize this equation and find the roots. Okay, so here when you factorize this equation, you have x square. The two numbers that comes here, when you add it, you should be getting minus 7x, and when you multiply those numbers, you should be getting 12, positive 12. So if you look here, see, 4 plus 3, okay, minus 4 plus minus 3 gives you minus 7, and 4 into 3, minus 4 into minus 3 gives you 12. So the numbers are minus 4x minus 3x plus 12 is equal to 0. We have used factorization to solve this equation. Now taking the common x minus 4, and here you take minus 3, so you get x minus 4 equal to 0. So x minus 3 into x minus 4 is equal to 0 and x is equal to 3, 4. Okay, x is equal to 3, 4. First, we need to find the roots of this equation, x square minus 7x plus 12. We are factorizing it. When you factorize, the sum of those two numbers should be minus 7, and when you multiply those two numbers, you should get 12. So x square minus 4x minus 3x plus 12 equal to 0. Taking the common, then you are taking x out, then you get x minus 4 minus 3, then x minus 4 is equal to 0. So x minus 3 into x minus 4 equal to 0, x equal to 3 comma 4. So which means that B is a set which contains 3 comma 4 and A is 1, 3 and 4. Okay. B contains 3 and 4 and A contains 1, 3 and 4. So from here it's understood that B is a subset of A because A contains all the elements of B plus an extra element which is 1. Okay. So we write B is a subset of A. Clear? A contains all the elements which are present in B and also 1. Okay. So this is how we solve this. Clear? Now we will look at the fourth question. So the question goes like this. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? And the next one is how many like tennis? Okay. So first we will write the information that is given in the question. In a group of 65 people. Okay. So the total is 65. 40 like cricket. That is, we will denote it as N of C. Okay. N of C like cricket and 10 like both cricket and tennis. Okay. So which is N of C intersection T. C denotes cricket and T denotes tennis. Okay. So C intersection T is equal to 10. Clear? So this total 65 means it is N of C union T is equal to 65. So we have these three information given in the question. N of C union T is equal to 65. N of C is equal to 40. That is the number of people who plays cricket. 40. N of C intersection T. Common. The number of people who like both cricket and tennis is equal to 10. We will write the equation first. N of C union T is equal to N of C plus N of T minus N of C intersection T. Okay, we will just draw the Venn diagram. C, T, C intersection T. Okay. Okay. So we have this set for C, that is cricket, then tennis, then the common area, that is C intersection T. Now we need to find how many like tennis only and not cricket. How many like tennis only and not cricket? Okay. So that is this shaded region. How many like tennis only and not cricket? So we cannot take this common area because it's mentioned not cricket. Okay. So first we will solve this. 65 is equal to 40 plus N of T minus 10. Okay. So 40 minus 10, 30. So 65 minus 30 is equal to N of T . Okay, so we have n of t is equal to 35. Okay, n of t. That means this entire area, this from here to here, that is n of t. So, n of t is equal to 35. And we need to find, this is the number of people who likes tennis. Now, we need to find how many like tennis only and not cricket. So, for that, we need to subtract this common portion. This common portion, it's 10. So, 35 minus 10, that is 25. Okay. So, that is the number of people who like tennis only and not cricket. Okay. I will just explain it once more. We have n of c union t, the total number, that is 65. Then the number of people who play cricket, that is 40, and n of c intersection t is equal to 10. Okay, n of c intersection t is equal to 10. Now we just write the equation, that is n of c union t is equal to n of c plus n of t minus n of c intersection t. Okay, so n of c union t, that is total 65 is equal to n of c is 40 plus n of t, we need to find n of t minus n of c intersection t, that is 10. So, 65 minus 30 is equal to n of t. The number of people who play tennis is equal to 35. Now, we need to find this shaded region, that is the number of people who play tennis alone and not who likes tennis alone and not cricket. So, that is 35 minus 10. 10 is this common area. We subtract 35 from 10 and we get 25. Okay. will see some of the previous year questions that has been asked from this portion. So the first question is, this question was asked in the merged cycle of December 2020 and June 2021. So the question is, identify which one of the following statements is incorrect. Okay, so we will look in detail each option. First one, if x intersection y is equal to phi, then x minus y is not equal to x. Okay, so if x intersection y is equal to phi, then x minus y is not equal to x. So x intersection y is equal to phi means there is nothing common between x and y. Okay, so this is x, this is y. Okay, so x intersection y, there is nothing common between x and y. So when that is the case, x minus y is not equal to x. That is a statement given. So x minus y means you are subtracting the entire elements of y from x. Okay, so this is the first statement, x intersection y is equal to phi. Now let's take an example, x equal to 1, 2 and 3, y is equal to 4, 5 and 6. Okay, x equal to 1, 2 and 3, y is equal to 4, 5 and 6. Here you need to subtract y from x. Okay, so when you subtract x from y, what you do is you subtract the common elements which are present in both these sets from x. Okay, so here you know that there are no common elements to be deleted. So the answer would be 1, 2 and 3. When you subtract set y from set x, what you usually do is you will be subtracting or you will be deleting the common elements present in these both sets from x. But since here there are no common elements, there is nothing to be deleted from x. So we just write that set itself. So x minus y is equal to 1, 2, 3, which is the set x. So here the statement is x minus y is not equal to x. So that is a wrong statement. Okay, x minus y, it should be written as x minus y is equal to x. Okay, x minus y is equal to x. So the first statement is wrong. Now we will look at the second other statements. Okay, so the second statement is x minus y is equal to x intersection y complement. So the first statement is false. Now we are looking at the second statement. Second statement is x minus y is equal to x intersection y complement. Okay, so we will draw that. This is x, this is y. This is a universal set which contains the entire elements of x and y. So x minus y. Okay, so this is x minus y. X minus y means you are subtracting or deleting the common elements which are present in both x and y from x. Okay, so the shaded portion represents x minus y. So x minus y is equal to x intersection y complement. Okay, so y complement means the area which is outside this y. Okay, you do not count this particular circle y, but the other portions which are outside the circle. Okay, that is y complement. Okay, complement means, see, I will just explain what is a complement. You have A here, You have a set A here, you have the universal set here. A complement is this one, the entire portion outside the circle A. The entire portion outside the circle A is A complement, okay. So, the universal set is equal to A plus A complement. A complement can be represented either using this symbol or this, okay. So, this is A complement, the entire portion outside the set A. So, universal set is equal to A plus A complement, okay. So, here the statement is x minus y is equal to x intersection y complement. So, y complement is the entire area outside y, including this x, okay. The entire area outside y including this x, okay. Now, here it's mentioned x intersection y complement, okay, x intersection y complement, that is the common area between x and y complement, okay, the common area between x and y complement. So, if you are looking at the common area, this is the only portion, this one, that is common between x and y complement, okay. This is the only portion that is common between x and y complement, clear. So, this statement is correct, x minus y is equal to x intersection y complement. Intersection means the area that is common between x and y complement. So, this is the only area that is common between x and y complement. So, this statement is correct. So, the second statement B is true. Now, C. The third statement, complement of a universal set is a null set, okay. So, this is a universal set, this entire area, okay. This entire area is a universal set. Universal set contains the elements of every set that are present, okay. So, complement of a universal set. So, U complement. So, since universal set contains every elements, complement of a universal set is a null set. That statement is true. C. Since universal set contains every element that are present, the complement of a universal set is a null set. So, C is true. Now, D. Now, D is intersection of two disjoint sets is a null set. Intersection of two disjoint set. What is a disjoint set? So, disjoint set means there is nothing common between those two sets, okay. So, this is how we represent two disjoint sets, A and B, okay. So, there is nothing common between A and B. So, intersection of two disjoint sets, see, for example, if A is 1, 2, 3, B is 4, 5, 6, okay, intersection of A and B. Since there is nothing common between A and B, the intersection of A and B gives you a null set, clear. So, the intersection of A and B or intersection of two disjoint sets gives you a null set. So, option D is also true, clear. So, the answer to this question is, which of the following statement is incorrect? The first statement is incorrect, that is x intersection y is equal to 5. That means x and y are two disjoint sets, there is nothing common between x and y. Then x minus y is not equal to x. That is a statement given, but actually x minus y will be equal to x if x and y are disjoint sets. Hope that is clear to you. Now we will look at the next question. This question was asked in December 2022. Okay, so I'll just read the question. If A, B and C are three different non-empty sets, then find which of the following are correct in laws of the set operation. Okay, so we will look each option in detail. First one, A intersection phi is equal to phi. Okay, so A, we have a set A, say A equal to 1, 2 and 3, and phi is a null set. Okay, there are no elements in null set. So A intersection phi is equal to phi. Intersection means we need to find the common elements between A and phi. So A intersection is equal to phi. That statement is correct because there are no common elements between A and phi. Okay, so A intersection is equal to phi. Correct. Then next one is A intersection B union C. A intersection B union C is equal to A intersection B union A intersection C. Okay, A intersection B union C is equal to A intersection B union A intersection C. This statement is correct because this is a distributive law. According to the distributive law, A intersection B union C is equal to A intersection B union A intersection C. So this statement is also correct. Okay, then the third one is A intersection A complement is equal to phi. That is a null set. So this is A complement, this is universal set. Universal set contains the entire portion A and A complement. So the statement is A intersection A complement. Okay, that is what is common between A and A complement. See, if you look here, you can see that there is nothing common between A and A complement. So A intersection A complement is equal to phi. Then option D, B minus A is equal to B complement intersection A complement. Okay, B minus A. So okay, so B, this is B, this is A. Okay, so B minus A, see, this is B minus A. Okay, B minus A is this shaded portion. So B minus A is given as B complement intersection A complement. Okay, so this entire portion is B complement including A, and A complement is everything, A complement is everything except A. B complement is everything except B. Okay, so B complement is everything except B. A complement is everything except A. Okay, so it's stated here B minus A is B complement intersection A complement. Okay, that is not true because this outer portion is common for both B complement and A complement. So that is not true because we need to get this shaded portion. Okay, since we need to get this shaded portion, that is not true. So this option D is not true because B minus A, okay, B minus A can be written as B intersection A complement. Okay, B intersection A complement. So if this was a statement, then it would have been true. Here it's written B minus A is equal to B complement intersection A complement. So we need to get this shaded area, this one, that is B minus A. So when B complement intersection A complement comes, we do not get this area. Okay. Then the next option is A union B complement, A union B complement is equal to A complement union B complement. Okay, this is a statement that is given, but according to De Morgan's law, A union B, the whole complement is equal to A complement intersection B complement. This is the right statement. According to De Morgan's law, A union B complement is equal to A complement intersection B complement. Okay. So, so this is the correct one. You can just put some value for set A and set B and check this, whether this is correct or not. Okay, so this is the actual one. So here option A is correct. A intersection phi is equal to phi. Then option B is correct. Okay. Then option C, which is A intersection A complement, yes, that is also correct. D is wrong and E is also wrong. Okay, D and E are wrong. So the answer would be which of the following are correct. So A, B and C are correct and D and E are wrong. Clear? Now let's look at the next question. This question was asked in June 2023. So this question looks a bit lengthy and confusing, but actually this is very easy to solve if you know Venn diagram. You can easily solve this question using Venn diagram. Okay. So the question is which of the following are correct in the case of theory of sets. Okay. And for 5 statements are given. So if you look at this options A, B and D, you can see that the LHS side is the same. Okay. Look at the options A, B and E, the LHS is same, the difference is in the RHS. So if you can just draw the Venn diagram for any of this option, then the LHS is solved. Then you need to look only at the RHS side. Okay. So we will solve this. The first one is, you need to see whether the LHS is equal to RHS. So A union B complement intersection A complement union C intersection B union C complement is equal to A intersection B intersection C union A union B union C. Okay, we will solve this using the Venn diagram. So first one is A union B complement. We will draw the Venn diagram for that one. A union B complement. Okay, so this is A, this is B, okay, and this is the universal set, you know that. So A union, okay, so you need to take the entire portion of A since it's union. B complement means everything that is outside B. So this is A union B complement. Clear? So this shaded portion represents A union B complement. Next one is A complement union C. Okay. Next one is, this is A, this is C. Now A complement union C. A complement means everything outside A, and A complement union C. Okay, so union C means the entire portion of C and everything outside A. Okay, this is A complement union C. This is A union B complement. This is A complement union C, and the next one is B union C complement. This is B union C complement. So this is B and this is C. The entire portion of B and B union C complement. Clear? So that is B union C complement. This is A union B complement, A complement union C, B union C complement. Okay. So complement means I have already told you. See, we have a universal set. So here you have a set A. This is A complement, this is universal set. So universal set is equal to A plus A complement. Okay. So complement means the portion, if it's A complement, that means the portion outside that of the set A. That is A complement. Okay. So now we have seen the LHS side. So now if you look here, it's intersection. Now you need to look at the common elements, okay? Common elements in these three sets. So here, if you can see A union B complement, it covers the set A and the outside portion. Here it covers set C and the outside portion, okay? Here it covers the set B and the outside portion. So if you look here, what is common? This intersection. This portion. See, A intersection B, this A intersection C and B intersection C. Okay? So that is common. If you look here, see this middle portion is common. This A intersection B, A intersection C and B intersection C. Okay, intersection means you need to take the only the common area between these three sets. Okay, so if you look that only this middle portion is, you can take only this middle portion because A and C, see there is nothing common between A and C, only this middle portion is common. Okay, now we will see the RHS side, that is A intersection B intersection C. A intersection B intersection C. Okay. So this is the area. When you say A intersection B intersection C, union A union B union C. Union means you need to take everything. A union B union C. Okay? A union B union C. A intersection B intersection C, this portion, union A union B union C. Okay. So now if you look at the LHS side and the RHS side in the first option represents this entire three sets A, B and C and this common area. So which means that the result is this entire three sets A, B and C. You are covering the entire elements of A, B and C. But if you look at the LHS side, that is not true. You can see this intersection of these three sets, you will not be getting the entire portion of A, B and C. So the in the first option, LHS is not equal to RHS. Okay. In the first option, LHS is not equal to RHS. Now we will look at the second option. So option A is not true. And in the second one, again the LHS is same. A union B complement intersection A complement union C intersection B union C complement is equal to A intersection B intersection C union C again A intersection B intersection C. This one A, B and C union union A union B union C the whole complement. Union A union B union C. A union B union C. Okay. A union B union C the whole complement. When you say the whole complement, this portion. Okay, this portion comes. A union B union C the whole complement. That is the area which is outside A, B and C. Now let's look at the LHS and RHS side. So if you look here, this outside portion, see outside portion is common in these three sets. Here it's intersection, okay. Intersection. Outside portion is common in these three sets and also A intersection B intersection C, okay. So this area is also common in these three sets. See, if you look at the Venn diagram, this A, B and C, the A intersection B intersection C. See, A intersection B, A intersection C, B intersection C. So this area is common and also this outside portion, that is the complement of these sets is also common. So if you look here, in the RHS side, A intersection B intersection C, union A complement, union A union B union C the whole complement, that is the outside portion. So LHS is equal to RHS in option B. See, A union B union C the whole complement. Okay, A union B union C, the complement of that is the outside portion. So if you look here, see the outside portion is there and also A intersection B intersection C and that is also common. So LHS equal to RHS in option B. Okay. So option A is wrong, option B is correct. Now we will look at option E. Okay, because the LHS is common for these three options. For option E, again A union B complement intersection A complement union C intersection B union C complement. Okay, so that is noted here, is equal to A intersection B intersection C. Okay, intersection A complement intersection, okay, A complement intersection, B complement intersection, C complement, A complement intersection. So which means this is equal to A complement intersection, B complement intersection, C complement. Okay. This A union B union C the whole complement is equal to A complement intersection B complement intersection C complement. Okay. This A union B union, the expansion of this A union B or the A union B union C complement can also be written as A complement intersection B complement intersection C complement. Okay. So A complement means the area outside outside the realm of A. Okay. B complement means the area outside the realm of B, which includes A and C. Okay. And C complement means the area which is outside the realm of C. Okay. Now it's the intersection. So what is common between A complement, B complement and C complement? So the common area is this outside portion. Okay, which is same as A union, B union, C, the whole complement. So option B and option E, both are correct. Okay. So if you look at the LHS and RHS side, you can understand that option B and option E are correct. So these three options, LHS are the same. You need to look at the RHS in order to understand whether these options are correct or not. Now we have two other options left, that is option C and option D. Okay. Option C and option D. So option C is A union B intersection C is equal to A union B intersection A union C. Option C is A union B intersection C is equal to A union B intersection A union C. Okay. So this is distributive law. This is correct. A union B intersection C can also be written as A union B intersection A union C. So this option C is correct because this is distributive law. Now option D is A intersection B union C, A intersection B union C. Okay. So A intersection B union C, when you expand it, you can write it as A intersection B union A intersection C. Okay. Here the option D is given A intersection B union C is equal to A union B intersection A union C. That is wrong. According to distributive law, you write it like this: A intersection B union C is equal to A intersection B union A intersection C, and option C is A union B intersection C is equal to A union B intersection A union C. This is distributive law. Okay. So when you look at these options, option A is correct, then option E is correct, and option C is correct. Okay. So option A is wrong. So B, C and D are the correct options. Okay. So I will just explain it once more. You have a question where you need to check whether the LHS is equal to RHS. So even though this question seems so lengthy and confusing, I told you we can solve it using the Venn diagram. Okay. So we need to draw the Venn diagrams for LHS and RHS, and by cross checking it, we can easily find the answer for this question. So with this, we conclude this question answer section for the set theory. Hope you have understood these questions really well. Thank you.